Hello everyone, welcome back to this channel. Till now we are moving ahead with the pattern to some pattern, and in the previous video also we have solved a problem to some using the two pointer pattern. Now considering the two pointer pattern in the last video where we have solved the problem, after sorting the array, the pointer movement itself becomes a powerful optimization. And today in this video we are going to just take our next logical step in order to solve a problem threesome using the same pattern, two pointer pattern. Again we will be seeing the multiple approaches that how we can approach this particular problem to solve in a very optimized manner. So we will just move step by step with the different approaches. So after looking at this threesome problem, it might look somewhat harder at the first glance, but as we move forward in this video, we can come to know that if we are having a good understanding of the problem, the twosome problem which we have already solved, the different approaches which we used, if we are having a good understanding of it, we can solve this problem very easily. So let's just understand the problem statement first, and then we will move forward along with the approaches. So the problem statement says is that we are given with an integer array nums, and we have to return all the unit triplets. Unit triplets means the set of three elements, and the nums of I, nums of j, nums of k, such that the indexes I and j, I and k, and the j and k, these all indexes are different from each other, and the nums of I plus nums of j plus nums of k is equal to 0. It means we have to find the triplets, the unit triplets from the input array, which sum up in order to give this target 0. And the solution set must not contain the duplicate triplets. Duplicate triplets means what? Like it can be the case where the two triplets are there and only they are differ in the ordering of the numbers. So this is not said as the unique triplets or the different triplets, but they are the same triplets only. Only the ordering of the numbers is changing. For example, one triplet is 0, 1, -1, and another triplet is -1, 0, 1. Only the ordering of the numbers is different. Rest the both of the triplets are same only. So we do not have to take the duplicate triplets in the resultant. Because there are some of the important points I have mentioned here. The order of the numbers inside the triplet does not matter, that I have already explained, and the order of triplets inside the output does not matter, that is also another case. And the duplicate triplets are not allowed even if they come from the different indices. So if the two same numbers are there from the different indices but they are the same number, so that is also not allowed, because they are going to give you the same triplet only. That we will see as we move ahead with the examples and the dry run. The input format is like an input, the integer array nums of length n. What is the size of array? It can vary from 3 to 3000, and whatever the elements which are present inside the input array, that element can vary from 10 minus 10 power 5 to 10 power 5. And what will be the output format? Whatever the result will be there, that will be returned as a list of unit triplets where the sum of elements is 0. So what it is saying the problem statement, we are given with an input array and we are given with a target 0. Now we have to find all the unit triplets which are summing up in order to give this target 0. So that is problem all about. Just what is the different change from the twosome problem? The different change is, the small changes that we have to now find for the three elements which are summing up to the target. So how we can solve this problem, how we can approach it? Now the very first approach, the simplest approach we can follow in that, as what we did in the twosome problem, we basically trying to check for all the possible pairs which we can take the sum and then check if it is equal to the target or not. So we can do the same thing in the threesome problem as well. We can try out all the possible triplets, and after taking every triplet, we can just take a sum of it, and then we can compare it with the target if it is giving the target or the sum to 0 or not. So this is how the brute force approach we can call it, or a naive approach which we can follow, that trying out all the possible triplet inside the input array. So here is the simple example which I have taken. This is the example, and this is of size 6. We can take the array, and the sum of the elements like -1, 0, 1, 2, -1, -4, and the target we are given as 0. Now we have to find for the triplets which are summing up to give this target 0. We can see -1, 2, and 1. When they are added up, they gives the target. They sum up in order to give this target 0. Okay. And also some of the elements, this -1, 0, 1. When they added up, they gives this target 0. Okay. So these two triplets we have found in this example, -1, -1, 2, and -1, 0, 1. So what are the possible triplets here? -1, -1, 2, -1, 0, 1. So the triplet -1, 0, 1 appears multiple times. We can see how many times it appears. We can say this -1, 0, 1, and one of the triplet it can form from 0, 1, -1, because only the ordering of the number is changing. So it doesn't mean that the triplets are the different ones. They are the same triplets. We can call them as the duplicate triplets. So we do not have to take the duplicate triplets. Just the unit triplets must be there inside the resultant that we have to return at the end. It is saying that -1, 0, 1 is appearing multiple times via the different indices, but it is included only once because it was the duplicate one. So this is the example one, And then this is example 2 where the nums array is 0 0 0 0. Now we can see here, when we find the triplet, it can be 0 0 0 from these indices, it can be from this 1 0, this 0, and this 0 from different indices, and these three zeros can form the triplet. So only one triplet will be there, 0 0 0, which is going to give the sum 0, because rest of all the triplets will be the duplicate ones, or we can say that the same triplets will be there just from the different indices. So although there are multiple index combinations, only one unit triplet is allowed here. And then checking the third example. Third example says is, this particular input array is given and we have to check for the target 0. Now we can see here no any triplet is giving the target 0. Like if we add 1 2 minus 2, it is going to give the sum 1. 2 minus 2 minus 1, it is going to give the sum minus 1. Like you can check all the possible triplets out of it, no any triplet is summing up in order to give the target 0. So therefore the output will be empty in this case. No three numbers sum to 0. Okay, so therefore the output will be 0 in this case. Okay, so now we have seen the three examples to understand this problem. Now let me just make the quick observations here that how we can move ahead with this problem. So already we have solved the two-sum problem, okay, and we know that what are the approaches which are required to solve the two-sum problem. Now what I'm going to do is I am just going to reduce this problem from three-sum to two-sum problem. How I can do that? I am having this input array and I am saying that I have to check out all the possible triplets. Like for the first approach we are discussing here, we have to check out all the possible triplets. And now what I can do is I can just fix one element here at the start, and for the rest of the part I can apply the two-sum approach. How I can do that? Firstly, I will just fix this first element, and I am saying indirectly that I am checking for all the triplets. So this first element is fixed right now, and now I am checking. Now I am applying the two sum on this rest of the array from 1 index to 5 index, and I am saying that I will be taking this particular index and I will be taking this index, and then I will try all the possible pairs in this part itself. Okay, and whichever pair will give me the target. Now what will be the target of for this rest of the part? See, whatever target I am looking for, this minus 1 is removed, means this first element is removed out of it. Now what I need means if I want the target as 0, so 0 minus minus 1, that is 1. Now the target which is remaining for this part is 1 right now. So I will be looking for the pairs which can give me the target 1. And once I get that pair, I can just take this first value along with it, and I can say that okay, this is a triplet which is giving me the target 0. That is the approach. So in the simplest way, just a small recap, fix this one value at the start and then apply two sum on rest of the part, where I will be just checking for the pairs for this target minus this first value. And once I get that pair, I will just add it with this first element in order to get that triplet. And once I get the triplet, I will just push it inside my result. And same I will be doing for every index. I will be fixing the first element and then checking for the rest of the part with the help of two sum. So this is how now brute force approach is going to be very simple in order to implement. So let's just get into the implementation part and implement it. Then we will move ahead with the same approach. So before moving to the implementation, let me just give you a quick review here that we are just going to focus on these key areas. We have to know that how we can reduce the three-sum problem to the two-sum problem, as I have told, by fixing one element and then solving for the rest of the part using the two-sum. And then we will, like when we will move to the two pointers approach, the optimized approach, we will see that how we can use that inside the loop, and then also we will see the how we have to handle the duplicates. So one important point again I have to mention here, this problem is all about handling the duplicates. That what is the idea which we will be using in order to handle the duplicates. Let's get into the implementation and understand step by step. So this is the first function which I have to complete for the approach 1, for the brute force approach. So let me just take the size of this nums array, int n equal to nums dot size, and once I take the size, then I will be running the loops. So what I will have to do, I have to basically check for the three elements that which are summing up to this target. So I will have to use three loops. Okay, so first loop will be for int I equal to 0, I less than n, and I plus plus. Now this particular loop, and what is the purpose of this first loop? The purpose of this first loop is to fix this one element, first element. And once it is fixed, now I will use two another loops in order to solve it using the two-sum problem, using the two-sum approach. So another loop will be for int, and from where the j will start? J will start from I plus 1 index. This is I plus 1, and j less than n and j plus plus. And so okay, let me just mark these in particular indexes here. So this is the I index, this is the j index, this is the I index, this is the j index, and this is k index. And another loop will be for k int k equal to, it will start from j plus 1, k less than n, and k plus plus. So these are the three loops, and now what we will do, we will just take the sum of it. So let me just take the sum explicitly. Int sum equal to nums of I plus nums of j plus nums of k. Okay, so we have taken this sum, and now I will be just making a quick check if the sum is equal to the target or not. And if I get this sum is equal to the target, then I will just return this triplets. Okay, or basically this problem is telling me to return the list of unique triplets. Okay, so list of unique triplets. So for that I will have to keep the vector here, and that will be vector of vector int. Okay, because it will be containing the triplets, and triplet will be a triplet in itself, will be in the form of vector, so that will be stored inside the another vector. And let me just call it as a result. And once I get this sum equal to the target, I can just take that result and push this particular triplet, nums of I, nums of I, nums of j, nums of k, that will be pushed inside this resultant. And once it is done, I can just come here and return this result. Okay, now it can be also empty, like if any of the triplet is not found, then the resultant will be empty in that case. So this is a simple thing. We have to just use the three loops in order to get it. And every time we will take the sum for that particular triplet, and we will check if that sum is equal to the target or not. If it is equal to the target, we will just push it inside the resultant, and at the end we will return it. If it is having the triplets, that will be the list of the triplets. Otherwise, that resultant will be empty. So let me just take input here. What is the input? The example. The size of array is 6, and what are the elements? -1, 0, 1, 2, -1, 4. -1, 0, 1, -1, 4. And what is the target we need? The target we need is 0 for the triplets. So let me just run it. Okay, so we can see that how many triplets are there inside this input array, which are summing up to give this target. One triplet we can see -1, 0, 1, and one triplet we can see -1, 2, -1, and another triplet is 0, 1, -1. Now here we can see this -1, 0, 1 and this 0, 1, -1. These both are the duplicate triplets. Only the numbers, the order of the numbers is changed. -1, 0, 1, 0, 1, -1. Only the number, the order of the numbers is changed. So that doesn't mean that the triplets are unique. These two are duplicate ones, and now we can see that whatever the brute force approach we have implemented here, it is not able to handle the duplicates, which is the core part of this problem. The important part is to be how the approach can handle the duplicates. Now, one thing which I can do here, one change which I can do, or I can say the small tweaks which we have to do in order to make this approach something that which can handle the duplicates. So instead of this resultant vector, what I can do, I can just use a set. We know the property of set, that whatever comes inside that set, it does not stores the duplicate things, it just stores the unique things. So I can just remove it, and let me just take a set here, and that set will be of what will be stored inside that set, that will be vector of int. Obviously we know that the triplets will be stored in that will be vector of int inside that set. Let me just name it as st. So the thing we have to change here is, whenever we are getting any particular sum as target, okay, sum equal to the target. Now we know that this particular triplet is summing up to that to get the target. First of all, I can just store it inside the, let's say, a vector. Let me name it as triplet. So this will be a vector in which that sum will in that particular triplet will be stored. That triplet will be nums of I, nums of j, nums of k. This will be stored, and after storing inside this vector, what I will have to do is, I will just sort this triplet. Triplet dot begin, triplet dot end. Okay, and once the sorting is done, we can just take this vector and put it inside the set. So set dot insert using the insert function, and I can just take that triplet and insert in this set. Now let me just explain how it is working. At the start, what I was doing, I was basically using a vector, and in that I was storing the triplet whenever I am getting that triplet is giving that target to 0. But in that case, all the triplets were coming along with the duplicates as well, and also means the copy of the the triplets which are giving that sum. So now what I am doing is I am using the set so that whenever any duplicate triplet comes, that should be rejected by that set, and therefore the unique triplets will be inserted only in it. So I am just taking a vector triplet here, and I am storing whenever I am getting any triplet which is giving this target. I am storing it inside this. Now, what is the use of this sorting? So once I sort that particular triplet, the order of the order of the numbers present inside the triplet, that is normalized. Means it is ordered inside the sorted order. It is present inside the sorted order. And when I move that inside the set, then set sees, means if that same triplet is already present inside the set, because also it is present in the normalized order, and if the already same triplet was already present inside the set, it will reject that triplet because it is a duplicate one. That is the use of sorting. We can sort the triplet so that the order of the numbers get normalized, and hence the set will it will be easier for the set in order to reject that triplet. Okay. So this is why sorting is done, and then when it is inserted inside the set, if it is a unique one, it will be inserted, otherwise it will be rejected by the set. At the end, instead of returning this result, what I can do, I have to whatever the result is present, that is present inside the set, so I have to return that set, but that particular result is in the form of vector int. So I will just take that set, and I will return it in the form of vector int. This is vector int, and here I can just take that set starting from beginning. Whatever the triplets are present in it, they will be returned. So this is what we have to do. Now let me just run it again, and it will now remove one of the triplet out of these two duplicate ones. Here we can see that the one triplet, this -1 0 1, it is present, and one triplet is -1 -1 2. These are the two triplets, unique triplets, which are present inside this input array, which are summing up to give the result 0, which is equal to the target. So this is the first approach, and let me just analyze that time and space complexity. So time complexity, we can see O of n cube time is required here, and because of the 3 loops. And so we have seen this particular problem. Now let's get into the another approach where we can see that how we can optimize this particular approach. So for this, I have taken another example where I will be discussing the another approach. Now this is the same example which I have taken, and let's talk about the another approach, that is the hashing approach, which we have also seen in the two-sum problem. So in the hashing approach, what we did in the two-sum problem was we just took one value, and then we saw that okay, we are having this target and we are already having this value. Then what is the another value we can take that which can sum up to that target? So that was the approach in the two-sum problem. But here we are solving for the three-sum, so we need that 3 elements in order to give that target. So the same intuition which we have seen in the brute force, we will fix one value, and for the rest of the part of the array, we will be using the two-sum problem by solving it with the help of hashing. So what we have to do is we have to just fix one element here. This one element, let's say I have fixed this particular value, and for this rest of the part, I will be just solving it like a two-sum problem using hashing. So let me just perform a dry run here so that we can get a clear the more understanding. So I will be just taking a set here, because obviously we will have to check for the existence of that when we are solving for the two-sum. So basically we will need two set here. One set which we will be using inside the loop, means after fixing the value, when we are solving for rest of the part as a two-sum problem using hashing, for that we need the set in order to check for the existence of the elements, and another set we will have to take in order to put the result, means the unit triplets inside that set. So the two sets will be taken. One set is this, and another set will be for the result. So let me call this particular set as set 1, and let me call this set as set 2. So this is how we will be taking, and now let me just perform a dry run here, simple dry run. So I is now present at this 0 index. Okay, so we have taken like with the help of outer loop, we will be doing this. We will be fixing the value. So once the value is fixed, now this problem will be taken like for the rest of the part. For the rest of the part, we will be solving it as a two-sum problem using hashing, as we did in the previous video, the previous problem. So let me just take it as j index, and now let me just also take the target which I need. So target is 0, which is the actual target I want. And now after fixing this one value, what is the target remaining in order to solve with this two sum? So already the target is 0 and one value I have already fixed -1. So now what is the rest of the value I need from the particular pair with this two sum? That will be 1 in order to give the sum 0 equal to the target. So 0 minus -1, that will be 1. That will be a target for this two sum problem where we are solving for the rest of the part. So let me also take that target as well, so that I can have more clarity. This target will be 1 for the rest of the part. So this is the target. Now we will start from this j index. So we are now seeing that this j index is having the value 0. So the value 0 and the target which we want, 1. So now value is 0 here, and 1 minus 0 is 1. So we have not seen in the set yet. So this is the set for the existence check inside that first loop. We have not seen target minus this 0, 1 minus 0. So we will just take this value and put it inside the set. 0 will be present inside this set too. And now this j moves ahead and it will now see a 1. So target minus 1, 1 minus 1 is 0. Have we seen inside the set? Yes, we have seen. So now what is the conclusion we can make from here? Okay, so this j index is pointing right now at this second index. This j is pointing at this second index right now. So we can see here what is the triplet which can be formed. One is the fixed value, this -1. Another value is this 1. And what is the need? Means which I am checking for. So already I am having -1 as a fixed value. I am having this 1 here, and now I am checking for the target in this two sum for the target 1. So 1 minus 1 0. I have already found inside the set. So what will be the triplet formed? Triplet will be -1, this 1, and the need which I am checking for, that I have already found inside the set because it has been encountered in this array before. So what will be the set, the triplet, sorry, that will be -1, this 1, and this 0. This will be a triplet which is giving the sum 0, which is equal to the target. Now before moving ahead, this 1 has to be inserted inside the set, so 1 is inserted here. Okay, and now this j moves ahead. When this j moves ahead, now we are already having this fixed value -1. We are having this particular nums of j2, and inside this two sum problem we are checking for the target 1. So already I am having 2. Then what else I need in order to get the target 1? That will be 1 minus 2, -1. -1 I have not seen inside the set, so I will just take this 2 and put it inside the set here. Okay, so this particular 2 is present inside the set now, and once we have done that, then this j will move ahead, and now it will check for minus. Okay, now we are already having the fixed value -1. We are having this -1. We are checking for the target 1 here inside this particular part, and for having 1 minus -1, that is 2. We are checking for 2 inside the array, and means inside the set we can say. So inside the set we can see that okay, 2 is present here. It means in some part of the array that 2 is already present. So what is the triplet which can be formed from here? That will be nums of I, this nums of j, and that particular need which I am looking for, that is 2. So -1, and this 2 will be another triplet. Now is it the different one or the same? It is different one. So -1, and 2. It is the another triplet which is summing up in order to give the target 0. So now this -1 will be taken and put it inside the set. And now this j moves ahead and it will now see a -4. So already this -1 is already fixed, and now we are having this -4. What else we need in order to get this target 1? 1 minus -4, that will be 5. 5 is needed. 5 is not present inside the set, so we can just take this -4 and put it inside the set. And now this j moves ahead, and therefore the loop gets ended. Okay, this loop gets ended. So therefore for this particular fixed value we have seen all the number of triplets, all the possible triplets which can be formed. Okay, so this is done, and now for the next time this I will move ahead, and once this I moves ahead, then the next j will be starting from this particular index, and this particular process will go on. So this is how we have to do for the hashing approach. With the help of hashing approach we can optimize it, and let's just implement it, and we can see that how the time and space complexity is optimized. Okay, let's just come here, and this is the second approach which we have to complete. Let me just remove it. For this, firstly I will be taking the size of this nums.size, and after taking this, what I will have to do is I will just take a set here in order to put the result in that. So that is set, and that will be a vector that will be storing the vector, means the triplets. So vector of int, and that I will name it as set1. Okay, now I will be using one loop for int I equal to 0 and I less than n, I plus plus. Okay, I have used this loop in order to fix the values, and inside this loop now I will be solving it as a two-sum problem using the hashing. So in this, now I will take another set, and that will see for that this particular set is for the existence check of the values. So that will be storing the integers, and let me just name it as by name set2. And here I will be using the another loop for int j equal to, see, now this particular loop is starting from I plus 1. So I plus 1, j less than n, and this is j plus plus. Now inside this particular loop, in the same way which I have done, already I am having a target. So I will be just taking a need. What I needed means inside that particular set, what is the need I am checking for the existence. That will be I am already having the target, and I have already fixed a value. What is that value? That is nums of I. That is nums of I, and one another value which I have fixed with this particular loop inside the two sum itself. Inside we are fixing, firstly I have fixed the with the help of outer loop, this nums of I, that I have fixed in order to convert the problem from three sum to two sum. And now when I am solving the two sum, that we already know, whenever we are having a j index, then we are checking for target minus j, and already I have fixed nums of I, that will be minus nums of j. So now I am having this need, and now I will be checking this need inside the set 2. So for this I will be just putting a condition, if inside the set 2 dot find, and in this I will be checking for this need, and that is condition set2 dot end. And in this, if I get this particular need, if I have found this particular need inside the set2, then what I will be doing, I will be just taking another vector in order to store it, just like I did inside in the previous approach. So that is by the name, let me take it as triplet. And here what will be the values? Nums of I, that will be nums of I, another value will be nums of j, and another value will be the need. So this I am looking for, and once I did this, I will just sort it. Sort this triplet dot begin, triplet dot end. And once I sorted it, then whatever the resultant vector I am already having in which I am going to put my result, that I will take set1 and insert that inside it. So set1 dot insert, and this particular triplet will be inserted inside that set1. We will now have to take whatever the value we are having, this nums of j, we will have to put it inside the set2. So that will be set2 dot insert, that nums of j will be inserted inside this set2. Okay, and once it is done, we can just come here and return what we have to return. We have to return this set1 itself, but in the form of vector of int. So vector of int, that will come here, and that will be set1 dot begin, set1 dot end. That will give us the result. So what we just did here, we just took a resultant set here, in which we will be putting the resultant set, and this particular set is for the existence check of the values. This is for the existence check of values. This is the thing, and okay, after this we are just solving it in the two sum way. The two sum problem is solved here. Some problem. Once it is done, we can get what are the triplets which are summing up to give that particular target. So let me just perform a run here, and let's check what's the output it is giving. So here we have also handled the duplicates as well, because we are using the set, so no any duplicate triplet will be coming in this. If any duplicate triplet comes, it will be just rejected from that set. Yes, we can see here the output is -1, -1, 2, and another triplet is -1, 0, 1. These both are the unique triplets, as we have already seen in the approach 1. Okay, so now let's talk about the space complexity and the time complexity. So for the time complexity, we are using two loops here, and one loop is used in order to fix the values, and for another loop we are using as part of the two sum problem. So their O of n square operations are required here, but along with it, inside this the second loop, the insertion is also done for those triplets. So let's consider that if m unique triplets are there which are going to be inserted inside the set 1, then for m triplets, because for one insertion log type of time is taken, the cost of insertion we can see, so that will be log of m. So the total time complexity will go to O of n square log m, where m is the number of unique triplets. Now talking about the space complexity, so again we are using the two sets. One set we are using in order to means a global set which will be storing the result, and another set is used just for the two-sum problem, for the existence checks of the values. So if the values which are inserted inside this set that are consider the n values, so n value for this set 2, and the if the m duplicate m unique triplets are there which will be stored inside the set 1 that we have already considered m. So O of n plus m will be the space complexity. So now we have seen this particular approach, and let's get to the another approach which is the final one, final optimization we can call it. So let me just take this particular example again, and let's perform a dry run on that as well. So this is the example we are looking for, and let me just remove this. So this is the approach, the two-pointer approach. We already know in the two-sum problem. Again, the same thing we are going to do. What I have just told in the before this particular approach, I just told you that we are going to focus on these areas, like the reduction from two sum to three sum to two sum. That we already saw that one by fixing one value we can convert it from three sum to two sum. And then second thing we are now going to discuss the two pointers inside the loop, and handling of the duplicates. Also we have seen that how we have to handle the duplicates. In the brute force approach we saw that we are using the set actually in order to handle the duplicates. We are not doing it implicitly. So what we are doing, whenever we are having an input array and we are checking for the triplets, we just take the triplet blindly and we are just relying on the set in order to clean those duplicate triplets. So that is what we are doing in these two approaches, and that is not at all efficient. So for that we are moving towards the two pointer approach. So these 2 points we have already seen: the reduction from three sum to two sum and the handling of the duplicates. That also we will see how we can do with the help of two pointers. And now let's just discuss the second point. So this is the example we have taken, and in the two pointer what we did was we basically sorted the entire array. What was the idea behind sorting? See, once the array is sorted, then the two pointer, whenever we are performing the two pointer, the pointer movements, it actually becomes a powerful optimization. So once we sort the entire array, the things gets normalized, means the numbers gets normalized and they comes in a sorted order, so that whatever the duplicate elements are there, they can come and grouped together. And when we perform the two pointer approach here, that becomes very simple. So what we did was we just started taking the sum, and then we are checking for the status of that sum. If that sum was greater than the target, then we are saying that okay, we have added some greater value, and because we are having a sorted array, so we can just move that right pointer back. And if we are having a sum less than the target, it means we have added some of the smaller value to that. So therefore we can just move our left pointer ahead, so that we can add some greater value to it, so that it can come closer to the target. And at the end, the point which we need, that if the sum is equal to the target, we just take that particular triplet, whatever giving that whatever sorry, the pair in the two sum, whatever the pair is giving me that sum, I can just take that particular pair and put it in my result. Now in this problem we are solving for, as we are solving for the three sum, so what we will do, what we will be doing, again we will be fixing one value with the help of outer loop, and then we will be covering for the rest of the part with the help of like solving it like a two sum problem with the help of two pointers. So let's start with this. First of all, I am taking this I index, means a kind of outer loop which will be responsible in order to fix the values, first value. And now this particular part is the second part, we can say, or the rest of the part on which we are going to apply the two sum. Two sum with the help of we are going to solve the two sum problem for this part, and that will be using two pointers. Okay. So this is something which we are going to do, which will make things very simple. But before doing that, we will have to firstly sort this particular part. So let me just sort this entire part, and after sorting it will become -4, and this will become -1, this will become -1, this will become 0, this will become, okay, let me just see from above what is the, so -4, -1, -1, 0, 1, 2, 0, and this is 1, and this is 2. So we have just sorted this entire array, and now we are going to do with the help of that whatever I told, that this particular is the fixed value, and for this fixed value we will be applying the like solving a two sum problem for this rest of the part using two pointers. This is the fixed value, and now taking the left pointer at the very first index and right pointer at the last index. So this will be the left pointer pointing at first index. This is the right pointer pointing at the last index, means at fifth index. Now we will start taking the sum. Now let's just take the target. What is the target? We are having the target as 0. Okay. And once we are having this target, what we can just do now, already we are having this fixed value -4. So what we will have to do is we will have to take this target minus this value so that we can check for this target in this particular part. Target minus -4. So 0 minus -4, that will be 4. And now the new target for this part will be 4. New target is 4. So 0 minus -4 is 4. And now we are looking for 0 sum inside this particular part. Now let's start taking the sum. So when we take the sum of this -1 and 2, the sum will be what? The sum will be 1. -1 plus 2, that will be 1. Now is it equal to the target? Means this is the new target. Just remember, this is the new target we are looking for. Is it equal to the 4? No, it is less than the 4. Therefore we have added something smaller. We will have to move this left pointer ahead. Once it is moved, now this particular value, so this -1 and 2 will be added. So this will again become a sum 1, which is again less than the target. Therefore we will have to add some more, like add a greater value. Now this left move ahead, and this is a 0. So 0 plus 2, again it is less than 4. So again left will move ahead. And this now 1 plus 2, it is 3. Again it is less than 4. So again this left will move ahead. And once these are at the same index, now we don't want any of the elements from the same index. So therefore we will not move ahead of this. So we will just stop this particular process here, and these two of the pointers will be removed. Now we saw for this particular fixed value -1, we do not get any of the triplet. So now what will be done? This particular I index will move ahead. Okay. And once it is moved, we will now have this particular part. Means this is the fixed value right now. And for this part, we will be solving as a two sum using 2 pointers. Again, see, whenever we are starting from this particular index, let's say 0 index, we must check if we are having the same value or not. See, what will happen if I am having this -4, and right now at this index also I am having -4. Then what I am trying to do, for the same fixed value, I am trying to find a particular pair which can add up to this fixed value in order to give that triplet. And now if I am checking for the same fixed value, I will be more or less searching in the same search space. I can call it as a strict search space, or I can call it as a subset of that search space which I have done in the previous iteration. So I will not be going to search for I will not be solving for the same fixed value, because for same fixed value, I am going to search in the same search space, and the same pair of elements I will be getting in order to get a triplet. So that will be a duplicate triplet, which I do not want. So this is how we are going to handle the triplet in this way. And there will be another case with the help of left and right pointer as well, that I will just cover in this when we will get to that situation. So this is right now the first this fixed value right now. And for this part, we are going to solve the two sum with the help of two pointers. Again, this left pointer will be present at this index, and the right pointer will be present at this right index. Sorry, at this last index. And now the sum we will again start taking the sum. So now right now sum will be -1 plus 2. That will be again 1, and which is now again we will have to set a new target. What is the new target in this case? The new target is the original target was 0, and 0 minus 1, 0 minus -1. The new target is 1. The new target is 1 in this case, and now we will be checking for sum 1. So -1 plus 2, this is a 1. It is equal to the target. Yes, it is equal to the target. Therefore we got a particular pair which is giving me this target, and whatever the value I fixed, that value along with these two values is giving me a triplet, and that I will be putting inside my resultant vector. So I will be just making a resultant in order to keep this particular triplets. So one triplet which I got right now is the fixed value -1, and another value this -1 and 2 out of these left and right pointers. Okay, once I get this particular triplet, now what I will have to do is, whenever I will be getting the same values for this left and right, let's say I am having this -1 and this 2. Now I will move this left pointer ahead and right pointer back. Now I must check if these left and right pointers are same or not. Means the value which they are containing in the previous part, it must be a different value. It should not be same. It's like this is -1, it should not be -1. If it is, then move this left pointer ahead. If this is 2 and this is again 2, then move this right pointer back. So this is how we have to do. We do not have to take the elements from the same index again. Now these, because these values are different, so we can again take the sum. So 0 and 1, this is again giving the sum 1, and we want that equal to the target. So that is, again we have got a pair which is giving the 1. So what the fixed value I am having -1, and again I got this particular pair which is giving me that new target 1. So adding all these three elements is giving me the target 0. So again I got a target, and I will just put it inside my resultant vector. So that will be fixed value -1, and another value is 0 from the left pointer, and another value is 1 from the right pointer. So this is how we have got the result. Again we will move this left and right ahead and back, and this is how this particular stop, and this process will stop. So what is the case where the process will stop in this situation? Where the left is, means left should be less than right, it should not be equal, otherwise it is no point of checking after that, because already we have checked all the pairs in that particular case. So this is how we have to do. And once it is done, now we are done with this fixed value. Now I will move ahead in order to check for other pairs. So now this particular part will be compressed to this. Now one important thing which I have told in the previous iteration, that -1 is the same value, same fixed value. I will not be checking for this, because if I am taking the same fixed value, I will be searching in the same search space, and I will get the same value. We can see here for -1, 0 and 1 are coming as a pair, because and that is already available in the case of this -1 as well. This is the proof of it, that whenever we are getting the same fixed value, checking for the same fixed value, we are going to search for the same search space. Okay, the strict search space or the subset of the previous search space, they are going to give us the same pair of elements. So don't check for the same fixed value. So this is how we have to move ahead, and already I have explained the process, that how we have to do it for 2 or 3 iterations, and it is like that for entire approach. Focus now, let's just get into the implementation and implement it. So this is the function which I have to complete, and this is, first of all I will be just taking the size, nums.size inside n. And before doing anything, firstly we will have to sort this entire array. So that is nums.begin and nums.end. Okay, and after sorting, now the two pointer will be now the two pointer technique will be applied. So first of all I will just take the outer loop in order to fix the value. So int I equal to 0, I less than n. Okay, not I less than n. See, because we have to get the triplet, so at least 2 values should be there after that fixed value, so that we can get the triplet if it is existing. So just this particular loop will be running n-1, n-2, n-3 till n-3. So I can write it as less than equal to n-3 or less than n-2, and then I plus plus. This particular loop is in order to fix the values. And after this, this particular now problem is converted into the 2-sum problem. Now we will be solving using a 2 pointer for 2-sum. So here another loop will be used. Now see, before this I have already explained that if we are checking for the another value, we have to check if it is the same fixed value or not. So for that we will be checking that if it is equal to the previous value or not, and first of all it should be greater than the 0 index. So for this I will be just putting a check here. If I is greater than 0 and nums of I is equal to nums of I minus 1. So this is the case, and if this is a particular case, then means firstly we should have the index greater than 0, and then we will checking for the previous values, comparing the values with the previous value. So if they are the same fixed values, then we will just continue in that case. We will just leave this iteration, skip this iteration. And once this check is complete, let's consider they are the not the same fixed values, they are the different fixed values. Now the problem is converted into the 2 pointer. So here the 2 pointers will be taken. First of all, int left pointer, which will be pointing at I plus 1 index, and another will be the right pointer, which will be pointing at the last index. So int right, and it will be pointing at n-1. And now this loop will be running. Now this particular loop will run till left is less than equal to right, sorry, left less than right. Okay. And in this loop already we are having these 2 pointers. Now we will take the sum, and the sum is nums of left plus nums of right. And after taking the sum, we will now check for the status of the sum, if it is equal to the target, less than the target, or equal or greater than the target. So now we have this sum, and now check if this sum is greater than the target. So if this is the case, it means we are having the sum is having some greater value. So we will have to take that right pointer back. So take this right pointer back, and if Like else if the sum is less than the target, it means that particular sum is having some value which is smaller, so we will have to move the left pointer ahead in order to get some greater value. And once this is done, the else case, only one case is remaining, in which the sum is neither greater than the target nor less than the target, so it is equal to the target. And now I will have to take one of the resultant vector in which I can store my result. So vector of vector int, which will contain the triplets, vector of vector int, and that I will just name it as resultant vector. Okay, and okay, so whenever I get the sum equal to the target, I can just take that resultant vector and push this particular uh, triplet into it. So push back that triplet. What is the triplet? Nums of I. Already it is fixed, so nums of I will be one value, and another value will be nums of left. Okay, and another value will be nums of right. So this is the triplet I am having. And after this, what I just explained to you, that after getting this triplet, we have to move this left and right ahead, means left plus plus and right minus minus. But before that, see, whenever I am doing this, I will have to check if this nums of left is equal to the previous value, or nums of right is equal to the previous value. If that is the case, I cannot take the same values. So in that case, I will have to move this left and right ahead. So just put this. First of all, let's just take this value of this nums of left and nums of right. So nums of left I am taking inside the L value, and like the left value, and nums of right I am taking inside the right value. That is nums of right. And once I did this, now I will be using the loops in order to move this left pointers. So first of all, the condition should be valid, that left should be less than right. So this is the condition, and after this I can check if this nums of left is equal to the L value. Okay, nums of left is equal to the L value, and if that is the case, then I cannot take the same value. I will have to move this left ahead. And same with the case of right pointer. In this again, I will be checking for left less than right or not, and if that is the case, I can just check for nums of right. That will be checking for nums of right if it is equal to the R value, and if that is the case, I can just take this R this right pointer and move it back. Okay, so that I cannot take the same values. And at the end, I can just come here and then return this result. So let me just explain what I am doing here. I have just took the resultant vector in order to keep the result, the triplets. And initially, the most important thing is to sort this entire array. Then only the two pointer will come into place. And then once it is done, so I can just run a loop, outer loop, in order to fix the values. And then the problem converted into from 3 sum to 2 sum, where I will be now handling, in this case, I will be handling for the duplicates, means for the same fixed value, same search space will be checked. So no need to check for the same fixed value. And here, one time the duplicate triplets are handled. And yes, when I am solving for 2 sum, after checking for this left and right pointers, means having the values or having any of the triplet from this left or right pointers, before this, like when we are moving this left and right, we will have to check if they are having the equal values as the previous ones. And if they are having the same values, then we cannot take the same value. We will have to move this left and right pointer ahead. This is again another thing in order to, or the another way in order to handle the duplicates. So these both, and this particular thing is the first step, we can say, and this is the second step by which we are handling the duplicates. This is how we have solved this problem, and let's just perform a run here. Okay, so this is the output, and now what's the problem? I have fixed the value, and then I am solving for the 2 sum, the rest of the part. Okay, so once I have fixed the value, I will also have to take it inside this in order to get the complete sum. That will be nums of I, fixed value, and also this nums of left and nums of right. That will be completely giving me the sum, and then I will check for the status of the sum. So if it is greater than the target, less than the target, or equal to the target, on that basis, I will be getting the triplets. Let's just again perform a run. Okay, so we got the triplets -1, -1, 2, and -1, 0, 1. These are the two triplets. Okay, now talking about the time complexity and space complexity. So here we can see that we are using one loop in order to traverse through the entire array, like till n-3 index. And for that, means to fix the values. So one loop is this, and inside this particular loop, we are actually using this while loop, where this left and right pointers are used. So left pointer is moving from left to right once, and the right pointer is moving from right to left once. Okay, without any reset. So they are just covering the array once, means traversing that particular part for every fixed value. we can say that time complexity is O of n square, and also the sorting is also done. So for that, n log n will be there. So the overall time complexity will be O of n square plus n log n. So that will be overall O of n square. That is the time complexity. And now talking about the space complexity. So if we ignore the space which is required to uh, return the output, so just ignoring this, uh, these only variables are used, like left pointer, right pointer, and these variables are used. So for that, the space is constant. We are just ignoring this output space. So in that sense, the time complexity is O of n square and the space complexity is constant. So this is all about this particular problem, and in the upcoming videos I will be solving the foursome problem and the k-sum problem as well with the help of recursion, by which how we can generalize this particular sum problems. So till then, just keep learning and keep growing. And this is Adit Bhattaria signing off.